Dear students, today I am going to teach you number systems in such a scientific way that whole chapter core concepts I will make you understand in 5 minutes. So, when we say natural numbers, what are natural numbers? Any number 1, 2, 3, 4, which we use for counting are all natural numbers. When we add number 0 to natural numbers, we get whole numbers. And when we add all the negative numbers like -1, -2, -3, -4, we get integers. So that's all. All natural numbers 1, 2, 3, 4, add number 0, that becomes whole number, then add all negative numbers, that becomes integers. And what are fractions like 1 by 2, 3 by 4, 27, pi 89? They are all fractions. When we add fractions to integers, we get rational numbers. After that, irrational numbers are there like root 2, root 3, root 5, pi, etc. When we add all rational numbers and irrational numbers, then we get real numbers. So that's all for our syllabus in the number system. Natural numbers 1, 2, 3, 4, then add number 0, then you get whole numbers, add all the negative numbers, then you get integers, add all the fractions, you get rational numbers, and rational numbers and irrational numbers make real numbers. Then let us see the core concepts of number system. Rational numbers. It can be expressed as fraction of integers like p by q, where q is not equal to 0. For example, 3 by 4. A standard form of rational numbers. P and Q should not have any common factor other than 1. So 2 by 4 is not in a standard form, but 1 by 2 each. Irrational numbers. It cannot be expressed as fractions of integers like pi. When we say pi equal to 22 by 7, that is a x approximate value, not the exact value. Rounding of rational number or irrational numbers. To round off a number to some given number of decimal places, we observe the next digit in the decimal part of the number. If digit is less than 5, we just ignore it and tell the number without it. For example, 1.23469. After rounding for two decimal places, just we write 1.23. So see 1.23. Just ignore after this because this is less than 5. If digit is 5 or more than 5, we add 1 to the preceding digit to get the required number up to desired number of decimal places. For example, if we have to round 1.23511, so after 2 3 it is 5. So just we have to say 1.24. Let us see how we compare two rational numbers. If we have to compare two rational numbers, if two rational numbers have the same denominator like 3 by 5, 4 by 5, just compare their numerator like 3 and 4. So if 4 is bigger, this 4 by 5 is bigger. If two rational numbers are having different denominators, make their denominator equal by taking their equivalent form and then compare the numerator of the resulting rational numbers. For example, if you have to compare 1 by 2, 3 by 4, how will compare? Just convert 1 by 2 to their equivalent form like 2 by 4. Then compare 2 by 4 and 3 by 4. Then we can see because the 3 is bigger than 2, that's why 3 by 4 is bigger than 2 by 4. Other way we can compare by plotting two given rational numbers on the number line. The greater rational number lies to the right of the other. After that, decimal representation of rational number. The decimal representation of rational number is either terminating or non-terminating repeating. So it can be 1.2 or 1.232323 it will go on. So you can say 1.23 recurring. You put a bar after 23. So what is irrational number then? The decimal expansion of an irrational number is neither terminating nor repeating. And rounding of number to a given number of decimal places. So as you already saw, sometimes it is easier to write the approximate value of real number up to a desired number of decimal places. So 1.24345 we can write 1.24. That's all for the chapter 1 core concepts. Thanks.